trying to show you how to do it. What I'd like you to do is just pay attention, and if you want to write on the back, you can. This is really for your own notes. It's not anything that you're going to turn in. This is just for you to learn it. There will certainly be time later when I will need you to show your work on a separate sheet of paper. All right, so now, we're looking for the unit deciliter. All right, now tell me what a deciliter is. Is it something that's larger or smaller than a liter? This is what we did yesterday. Deci is down here. It's underneath the base unit, so it's going to be smaller. Okay? All right, how many deciliters are there in 35 milliliters? All right? Now, this is going to be a math problem. And what is this 35 milliliters? When, in your math class, this would be called the given information, wouldn't it? It's called the given info, or given information, all right? And this is the unit that we need, or that we're looking for, all right? Now, I have to do conversions. I have to use what's called a conversion factor here in order to get the units that I'm looking for and get rid of the units that I don't want, okay? Now, I don't want my answer to be in milliliters. I do want it to be in deciliters. So I'm going to put deciliter in the numerator, and I'm going to put milliliter in the denominator, all right? And I'm going to put a line here because right now I don't want you to worry about the numbers. I want you to think about the units and why I'm putting them where I am putting them. Also remind me if you can't see what I'm writing, let me know and I can adjust it. Yes, Maddie?
Is that x? Is it like is it something variable x? Or
that's a multiplication. It's times. Yeah, I'm multiplying here.
Yeah, can we do that instead?
You want a dot? How about I do? Sometimes they do this, like on a spreadsheet, that little asterisk. But I can put a multiplication sign if you want me to. I mean, a little dot. Okay, I can do that. I'm just going to make a little note for right now that we're doing that. We're going to multiply here. Okay, now, this is the rule that I want us to really pay attention to.
There? Yes, ma'am. Here, please.
Well, hold on. Why am I trying to put why am I putting milliliters down here in the denominator? And why am I putting deciliters in the numerator? Grant, say that again. Yeah, the answer that I want, or the unit that I want, or that I need is deciliter. I want to end up with this right here in the numerator, because that's where I want it to end up, you know, at the end of the problem. Milliliters does this thing. What's that called in math when you have something on the top that's the same as something else on the bottom? I'm going to cancel them, all right? So I'm doing something called dimensional analysis, and I am canceling those units, and that's important. Now, so I want to cancel the given units. All right, now, here's the rule. What is the bigger unit of those two units, deciliter or milliliter? It's deci. Now say, how are we supposed to know that? If you look at the new worksheet that I gave you, where's the big end of this scale, left or right? It's left, which is kind of backwards, isn't it? These are the bigger units, and these are the smaller units. All right, so here's my deci, here's my centi, right? Okay, so when I'm going from centi to deci, all right, I see that deci is the bigger unit. I'm going to do this. I'm going to put a 1 in front of the bigger unit. And then I'm going to put a 10 in front of the smaller unit, but I've got to raise that to a certain power. Okay? I'm raising my 10 to a power. Now let's decide what power we're going to raise it to. Look at the difference between deci and centi. How many steps are there, or how many powers of 10 are there between those two prefixes? Just one. Okay? From deci to centi, I just have one step. And looking at how we looked at it yesterday, going from top to bottom, that's just a one-stepper on that scale. Okay? And by one step, I mean a factor of 10. 10 to the first power. So I'm going to put a number 1 right there.
Lindsay?
All right, now, I'm going to write out what I did in steps, and then we're going to keep going. And I'm going to tell you what my son Josh, he's in the 6th grade, he said he came home from school and his teacher told him that what they were learning today, they weren't going to understand, okay? But they're going to work up to you have to start somewhere. I'm going to teach you something, you're not going to quite get what I'm doing, but as we go through and practice this, you'll see the pattern and you'll see why we're doing it, okay? Sometimes that's just the way it is. You don't understand it from the very beginning, but eventually we'll get to it, okay? So I'm going to write a little rule here, and this rule is important, okay? When you're converting between metric units, all right, when you're doing metric conversions, all right, when you do metric conversions, place a 1 in CL in front of the larger unit. All right, that's the first part of, of what we just did. All right, and then the second thing is place a positive power of 10 in front of the smaller unit. Whoops, I'm off the screen there. All right, that's it. That's the important rule that I want you to know on metric conversions. I'm kind of in a corner here, but that's what I want you to do. And that will help you in your math classes, and when you get to chemistry next year, you're going to need to, this is going to make it a lot easier for you. Brandon Dukes is right here. All right, you getting that down? All right, did we talk yesterday about how positive powers of 10 are a little bit easier to understand than negative powers of 10? Yes. Okay. All right, so if we're talking about 10 to the third, what number are we talking about?
300. I mean 10. I don't know.
No, you know what we're talking about. All right, if we're talking about 10 to the third, we're talking about 1,000. Okay. If we're talking about 10 to the negative third, what is that number? 1/1000th, right? 1/1000th. Okay. So
Mackenzie?
the reason we're doing this is because this way we only deal with positive powers of 10. You see that? You always have a positive power of 10 if you put the 1 in front of the bigger unit. All right, so let's go on to another, let's finish this problem and then go on to another one. Now this is very easy, and your elementary or middle school teachers probably taught you how to convert metrically by moving decimal places, and you can certainly do that, but I want to show you mathematically why that's working for us, okay? All right, so what's, to multiply all this out, this is how we do this in the calculator. We take 35, we multiply by 1, and then we divide by 10 to the 1. Well, everybody knows what 10 to the 1 is. What is 10 to the 1? 10, okay? But I'm just writing that out just so you can see that. So 35 times 1 divided by 10. Now, please tell me you don't need a calculator for that.
Madison?
35 divided by 10 is equal to, Grant, what is 35 divided by 10? 3.5, right? Now, what's the unit on my answer? It's the unit I originally started looking for, right? DL, how do you say DL? We're not talking about keeping it on the down low. We're talking about deciliters, right? Okay, deciliters. All right, very good.